Welcome, students. Today, I want to help you understand how to take a conic equation that's written in what's called general form and convert it to what's called standard form. First of all, let's do a quick review of conic sections. We have circles. Circles, this is the standard form where we have x minus our horizontal shift squared plus y minus our vertical shift squared equals our radius squared. So again, this would be a circle centered at the point HK and have a radius of R. Then we move on to ellipses. Ellipses always have a plus symbol in between here, and underneath the parentheses that are squared, we have an a squared and a b squared, and we always set it equal to 1. In other words, what we're really doing is we're dividing over the r squared in a sense, but there's coefficients in front of them that make it more elliptical rather than circular. And we can be longer horizontally if the a squared is underneath the x squared, or we're opened vertically if the a squared is underneath the y squared. A squared is always the longest. It's half the major axis, right? So our a is the major axis, or the major axis has a length of 2a. Our minor axis has a length of 2b, and we're centered at hk. Right? So very similar, just realize that we are always equal to 1, and we're dividing by a number over that gets us an a squared and a b squared. And the a squared is underneath the variable that it's longer. So if it's longer vertically, the a squared is under y. And a is always longer than b. But that's only true for ellipses. Once we get to hyperbolas, the a squared, again, it can be either underneath the x squared or the y squared, but if you'll notice that we've swapped it, I put the y squared in front. On the ones that are opened up and down, I put the x squared in front if it's open left or right. And again, we have our center at HK. We have we call it our transverse axis, which is twice A. I should have put that over here, really. The transverse axis is twice A. The conjugate axis is twice B. But again, our asymptotes are, this is the equation of alignment in point slope form, y minus the center of our hyperbola, its y value, plus or minus b over a if it is opened left or right. B is on top, a is on bottom, and then x minus our horizontal shift. If it's opened up and down, notice that the slope is flipped. It's a over b now, not b over a. So be very careful. By the way, once we have a positive slope, we have a negative slope. Those are those asymptotes. They're not horizontal, but the slant asymptotes that the hyperbola is getting closer to. Standard form of all of these expressions, circles, ellipses, and hyperbolas, are written in this form: ax squared plus by squared plus cx plus dy plus e equals 0. If you notice everything's on the left, it's equal to 0. What we want to do is we want to get this into those forms up here, all these different standard forms. That's why I didn't write it next under the standard form, is because it depends on whether it's a circle, an ellipse, or a hyperbola. And we do this by the process of completing the square, which we had a lesson on a while ago, but I'm going to do another one to reiterate. First, we will have a circle or an ellipse, though, if both the x squared and the y squared terms are positive. If these two leading terms are positive, it'll either be a circle or an ellipse. If one of the two is negative, then we get the hyperbola. You should never have both of them negative, because you could actually just eliminate the negative by multiplying by -1. So let's do an example. Let's take this 3x squared minus 5y squared plus 12x minus 20y minus 23 equals 0. First thing we do is we know that it's a hyperbola because our y squared term is negative. And then the second thing, the first step we're going to do is we're going to group the x terms together and group the y terms together, and then move the constant, this 23, off to the right side. So again, what I've done is I've taken the 3x squared and the 12x and pushed them together. I've moved the -5y squared over to next to the -20y, and I've added 23 to the right side. So again, I brought this over, and I've grouped the x terms and the y terms. The second step is to factor away the coefficient that's in front of the x squared term and the coefficient that's in front of the y squared. So what that means is, if you'll notice, this 3x squared, I factored a 3 away from this, and I factored a 3 away from the x term as well. So 12 factor out a 3 becomes this 4. We do the same process with the y terms. I'm going to factor out a -5. This -5 here that I factored away from the y squared, leaving just a y squared. But I'm also going to factor out a -5 from the y term. If I take a -5 factor away from -20, it leaves a +4. So basically, I'm factoring away that coefficient that's in front of the x squared term and the y squared term, but I do it from both terms. Now, the third step is to take half of the coefficient in front, that should be an in front of the x term and y term to use as in our factored form underneath. So what I'm saying is this. I look at this 4 here. If you notice, here's my 4 up here, right? I took 4, I took half of it, and I put it down here in my factored form of my x plus 2 squared. I took half of this 4 and I put it down here in the y plus 2 squared. Now the thing is, though, I got to realize that if I do that and I square this and FOIL it back out, I'm going to have a third term here that's missing. That third term, 2 squared, is 4. So I would actually put a 4 here. Same process here. If I FOILed out this y plus 2 squared and I 2 times 2 or 2 squared, I'm going to put a 4 right there. Now, the problem is, as I'm adding some extra values into the equation on the left, I got to add those values on the right. But be very, very careful. I didn't actually add 4. There's this 3 sitting out front that when I distribute in 3 times 4, that 4 actually becomes a 12. So this will become a 12 here. Likewise, this 4 that I put inside these parentheses, which is this FOILed, isn't 4. It's actually, when I distribute in this -5 to each term, it actually becomes a -20. So this third term here is a -20. And that's where I got these 3 terms down here. That's where I got that term, and then those 2 red terms, this 2 and this 2 were half of these. So basically, I've written the same expression. I've just added a little extra into both sides of the equation. Now what I'm going to do is I'm going to simplify. When I simplify and add these terms together, I get 15. So I have a 3 parentheses x plus 2 squared minus 5 parentheses y plus 2 squared equals 15. The last step is we're going to divide everything by 15. I'm going to divide this side by 15. I'm going to divide this side by 15 and this by 15. In other words, everything by 15. Okay, so when I do that and I simplify, I have it written here, 3 goes into 15 5 times, 5 goes into 15 3 times, I keep the minus here, and there is my hyperbola written in standard form, which I got from my original expression. If you have any questions, please contact me via email, or you can get on during my live class, online class times at 1 in the afternoon. Or set up a one-on-one appointment with me via email. And if you have any further concerns, please let me know.